Hi, I'm Alex, and today I'm wondering the question, can I become an expert in Minecraft using AI? Minecraft's a really in-depth game, so to become an expert, you need to definitely have knowledge in writing commands as well as tips and tricks to play the game optimally. So I wonder, can I use AI to help solve this problem? It can give us a great fishing rod. Bam. It can even help you fly. It can even kill all the creepers for me. And it can even tell me what's the best type of food in the game. Well, there's many forms it could take. Maybe it could be a chatbot or like an NPC in game, or it could even play the entire game for you like a real expert. For now, let's try to make a bot that we can interact with through the chat that can give us lots of information to become an expert really fast. Before pushing any technical challenge like this, you've got to figure out if what you're trying to do is even technically viable. Here you've got to figure out how to talk between an AI agent and the game Minecraft itself. So to make our whole app, we need to choose a language that serves as the core of what we're doing, and lets us interact between our systems. So here I chose to use Python, because it's easy to use, well documented, and has tons of different libraries we can use to make connections between maybe AI chatbots and the game Minecraft here. Now we've got to figure out how we're going to integrate the AI chatbot into our system. We could spend a long time developing our own chatbot system using OpenAI APIs, but instead we can use Voiceflow, which lets us easily create a conversational diagram and handles all the LLM and chatbot logic for us, letting us really focus on what we care about, which is definitely the features we can include, as well as the connection to Minecraft itself. And luckily, Voiceflow actually already has us sorted for communicating with Python, thanks to its easy-to-use dialogue API that lets any external application talk to a Voiceflow diagram using simple HTTP requests, and it also remembers the state of your conversation. And they already have a bunch of great examples on how to use the Voiceflow dialogue API in a bunch of different languages, including Python, which I'll be working based off of today. And by the way, all the code that you see today, you can find in GitHub repositories in the description below. Next, and the most complicated, we have to figure out how can we talk between Python and the Minecraft game itself. Well, I did some research and there's a few different options that we have. We can either use Minecraft's remote connection system, which lets us directly interact with the command line, or we could make our own full mod, which lets us really interact in a deep way with the game. In the end, I went with Archon because it's just much easier to implement rather than having to set up an infrastructure for developing a whole mod myself. That being said, in the long term, developing your own mod would definitely be much more robust and let you do a lot more with the chatbot, letting you maybe integrate new data from the game and new features as well. So yes, this project definitely looks viable. And now that we have a plan of action, let's get programming. So I actually was trying to develop my app right now, and I had a quick question on how to ask for the correct production environment of my bot, and I didn't know how to solve it. And when you're programming with Voiceflow, a really nice thing is the built-in chatbot that you can use to ask questions about how to develop with Voiceflow. So here I just asked it how I could pass the specific version of the production I wanted, and it told me I can add a header with the version ID being production. So this is similar code to what I have inside my real code. We can see here is where I'm setting my headers for our make requests, and I can just actually add on a header that says what version I want. So for example, version ID production, just like the chatbot told me. So let's run through quickly how this Voiceflow chatbot actually works. So any Voiceflow chatbot is built with a bunch of little blocks. Each of them has specific messages that are sent by the chatbot, choices we can take, or generation steps for the chatbot's logic. So here, this chatbot is actually quite simple and starts off with just saying a hello message and asking us what to do. It then has a bunch of options to choose which direction to go into. So either to give commands, tips, or if the user says goodbye or asks for nothing. So these are called intents, and we can write our own intents to describe like sort of what we want to do. So that if we say like give me a command, it'll understand that we want to go in the commands direction. So that depending on where it goes, if it asks for a command, it will go down here, and if it wants a tip, it'll go up here. The tip's pretty simple, so we'll go with that first. Pretty much the way it works is it asks the user what kind of tip they want and captures back the user's last message in a variable called last utterance. We're going to then send a message using the AI response AI block, and then giving it a prompt asking us to give a Minecraft tip for exactly what the player asked for. And inside the prompt settings, we're using GPT 3.5 Turbo with a quite large maximum tokens, and we're giving it some system information to give it information on who it is so that it can give a good contextual answer. Then we'll ask the user if it wants more tips, and if it does, it'll loop back around, and if it doesn't, it'll go back to this block asking if it needs anything else. Now in the commands direction, we ask the user what kind of command it wants. So we ask the user what kind of command they want, and then we use the set AI block to set a variable called candidate command to what the user wants using the AI, explaining exactly how it should fulfill the request, what kind of format it should give it back in, and some extra important details that we'll talk more about later. For this, we're using GPT-4 because we want a really strong answer, and we explain some context on how to properly generate commands here. Then what the chatbot does is it proposes the command it was going to execute to the user to see if the user's happy with it. And if they're happy with it, yes, they can go ahead. But if they're not, they can ask to try again, and then they can loop back. And then it will run the command, and with this big command keyword at the front, which we're then filtering for later to send that command actually in-game in Minecraft, which we'll see in a Python code. And then when we're done, it says goodbye in a funny way, again using a little simple AI prompt, and then ends the conversation. So let's take a look at how this first version of the bot works. So we can just ask our question. Let's ask for some tips, for example. Tips. And then let's ask it for where's the best place to go mining for diamonds. Where should I go mining? And then now we can see that the Voiceflow is going to give us back a quick answer and tell us information about the correct Y level to be mining at, which is super useful to be an expert Minecraft player. So let's say that we want to go on a big mining expedition. Let's ask it for a really good pickaxe that can help us mine lots of diamonds. So let's just ask this sort of vague question. Give me a really good pickaxe. And then it's going to prepare a command for us and return it. And this looks good to us. Let's just say yes. And boom. Now it gave us a really great pickaxe with great enchants so that we can mine super great. So here's a high-level explainer of how the Minecraft chatbot works. First, we're monitoring the chat logs for player messages received. Then, once we receive a player message, we package up this player message as well as our Voiceflow chatbot API key, and as well as the player's username to uniquely identify the conversation that's happening, all into one HTTP request that will be sent to Voiceflow. We then send this request to Voiceflow using HTTP, and it does all the chatbot logic in the cloud. And then it comes back to us with all the responses for what we want. So after receiving the responses from the Voiceflow chatbot, we parse through all the different messages it sent and split out the commands from just the normal conversational messages it has. And then the commands we send over remote connection with a /execute command, and then the messages we just send over the same remote connection but with a /say command so that we appear all nice and stylized inside the user's chat. So here's what happens inside the Python code. We have a Python file that lets us interact with the Voiceflow API by preparing a response that has the conversation, the user ID, the request, and the authorization key that we mentioned before. It then sends the response using the request system and returns the JSON answered back by Voiceflow that we can then parse later. So when the user starts interacting with the chatbot, it will send a launch message for the first time the user talks, but then after that, it's going to keep sending requests using this previous method with the payload type payload, and then having the text that the player said actually in that payload. And then each time we're getting a response back, we're going to be filtering through it. So we're going to be looking for the speak or text answers, which is just Voiceflow's ways of returning us text to be displayed. And then it might also give us some text that tells us that we're at the end of Voiceflow's answer, and at that point we just stop giving back answers. Next, we have our chat monitor that is really just looking into the Minecraft logs, checking at a regular interval, and then using a regular expression to find the player's messages and extract them, which is then used later. And then we have a separate remote connection sender, which just sets up a remote connection with our Minecraft server. And then each time we want to send a command, it will just directly through the remote connection send the command and then return the response we have or print an error if there's an issue. So this all comes together inside our main file. While the Voiceflow bot is running, we will look in the list of player messages to see if there's any new messages. If we have a new player message, we're going to print the player message to the terminal console so just we're sure that we got it, and then we're going to add the list of messages to deal with later. Once we're ready to deal with all those messages that we've collected, we then bring them all together into one long string and then send them to the Voiceflow interaction using this interactor and then user interaction. We then get the response, and for each message in Voiceflow's response, we're going to split it up. So if it begins with a command, we're going to parse the command right here, and then we're going to prepare the command to send using the Minecraft server using the execute command, and then we're going to send that command over the remote connection. If it's just normal text though, we just style it using some colors and then send it again over the remote connection. We just repeat that until we ask the chatbot to stop, and really with that we have a working chatbot. So that's useful. But let's say we were trying to have a conversation with our friend on the Minecraft server and we were done with the bot. So like say, hey Harry, Well, we can see right here, Voiceflow actually butts right back in and keeps asking us. And if I want to just talk to my friend, ignoring Voiceflow, like, do you have the diamonds? The Voiceflow is actually going to not understand. It's going to get quite annoying real quick. So we're going to fix this by adding a key phrase that you can prompt Voiceflow with. Like, for example, like hello Google. We can come back to our whiteboard and we can see that there's going to be some parsing just before the message gets sent to check if the user has said Voiceflow, and then if so, we can add them to the conversation. So here we're just going to say if the message has Voiceflow in it, we'll take that as our trigger phrase to start the conversation. And all we really have to do in our code is change right here. When we're creating a new conversation, like launching the Voiceflow conversation with a new user, before launching it, they're going to check if they said Voiceflow in their message. So by checking if the user has said Voiceflow, then and only then do we send the correct message. And otherwise, we're just going to skip and move on. So let's just say, hey, Harry. Voiceflow doesn't answer anything. But now, if we try saying, hey, Voiceflow, it does wake up and it starts responding to our commands. So another issue I encountered sometimes while using the bot is that the commands it would give would be incorrect, like they just wouldn't be a valid Minecraft command. So the first step I took to mitigate this is I made a test. It just asked if the command looks good before trying to run it. And if it doesn't look good, it tries again. But the issue I was having is that the LLM was just giving me back the same command or a same bad command over and over and over again. So how can we fix this problem? So Voiceflow actually has a really easy to use built-in system to pass back some memory to your prompt generation, here we're generating the command, so that the chatbot has an idea of the last command it tried, the fact it didn't work, and then to try a new different command. So the way we can enable that is in this step where we're setting with AI, we can change it from just using just the prompt that we wrote here to using a prompt and a memory. Now, if we test it, we can just test from inside Voiceflow, no need to be in Minecraft. Let's say, give me a sweet fruit. It'll try to give us a command. And let's say that command doesn't look good to us. We don't really want an apple. We can just say no, and then ask it to try again. And then now it will give us a different command. This time it gave us a golden apple, when otherwise it might have just given us the same command over and over again. Adding memory is a really great way to make the chatbot feel more organic and more like a real expert. So now that we changed this, we can see that sort of Voiceflow is using its memory of the conversation to give more relevant responses. Sometimes there's an issue where the bot sends the command we want, but inside of it, it's embedded inside a bunch of other text that it's trying to give. But when in fact, all we really want is the pure command itself. Now, what's going to happen here is when I tell it to run the command, it's going to fail. It tried to run the command, but nothing happened in game. That's because if we look on the back end, the command tried to run and then it got an error for incorrect arguments. So LLMs giving a little bit of extra text with their response, causing an issue, is a common problem in the modern day development of AI chatbots. And there's a few methods we might want to use to mitigate them. The simplest one to apply is to just change our prompt up a little bit, be more strict on what exactly we want. Here in the generate step, we can see that I asked it to give back exactly the command without anything else. And that does work quite well most of the time, but as we saw, every now and then, it might give a little bit of extra text. We could try to make this prompt more strict, like saying, important, give no extra text. So adding this step mentioning that it's important could really help in the generation. Another strategy that is also quite successful is telling the AI to insert certain key characters that we can then filter for. So how about now, we try to apply a little bit of logic and ask the LLM to encase its responses in ticks, for example, so that even if it adds an extra text, hopefully it will still insert those ticks and we can filter them out. And then we can add it in an example. Adding examples is often a really effective method to get better answers from the LLMs. So here if we just give examples where we put the ticks before the quotation marks, and then we can remove these quotes to make it more clear what we're trying to do. So now that we added this parsing for extracting the command exactly, we have a step between separating the commands where we extract the in between ticks and then send it over the remote connection. So now our final diagram looks a little bit like this. But now we've added in this little line of code that pretty much just checks, is there a tick inside the command? And if there is, it sort of cuts out the middle, the first element after the tick. Another thing we can change if we're having difficulty with the AI listening to our instructions is change the model. An actual great feature of Voiceflow is it supports us using multiple different large language models in the same flow. So here, for example, for most of the conversation, I could just be using GPT 3.5, which uses not a lot of tokens and is really cheap. But because this command generation step is a bit complicated, I might want to change it to GPT-4, for example. So for that, I can just go to the set AI step, change the prompt settings from GPT 3.5 to GPT-4 Turbo. Note this will use a lot more tokens, but we should get more consistent answers. Let's give it a shot. Help me find a fish. And here it did a great job. So let's go with this solution for now. Okay, so let's get this AI chatbot to prove to us that it can help us beat the game. So the first thing we need to do is to get to the end somehow. So hey, Voiceflow command, get me to the end. So now it's gonna figure out a command to get us to the end, and that sounds good. Let's hit execute, and now it's gonna boom. We're already teleported to the end. Crazy. I bet you didn't even know you could do that for command. Personally, I didn't. But let's say now we're in the end. We don't know how to beat the Ender Dragon. Well, we can ask it for some tips. So, tips. How can I beat the Ender Dragon? Okay, and boom, it responded to us with tons of great advice on how to beat the Ender Dragon that we can really apply right here. But let's say we didn't want to do the hard work. We just wanted it to get us to beat the Ender Dragon for us. No, yes, commands, kill the Ender Dragon. And yep. And I think we can all agree that that was pretty powerful, and we just beat the game so fast. So I think this AI pretty much makes me an expert in Minecraft. I hope by seeing this development process, you've been inspired to create something on your own, and you've been able to see what I've been able to make in just a couple of hours, and imagine all the things you could do yourself. Even if you want to extend this project, you could make it a full-fledged mod. You could put mini games or quests into the game using the AI system. You could even turn villagers into AI, or mobs into AI, or blocks into AI, or trees into AI, or apples into AI, or creepers into AI, or ender dragons into AI. It will prepare the command to be sent by putting the start at the start. That's unfortunate.